We are learning about factoring trinomials in the form ax squared plus bx plus c by grouping. We did this a little bit in 7.3, but we're going to spend some more time on it today. So I know I've got this one. I can use the grouping method to factor trinomials of the form ax squared plus bx plus c. So to factor trinomials by grouping, factor out the greatest common factor if there is one other than 1. For the resulting trinomial ax squared plus bx plus c, find two numbers whose product is a times c and whose sum is b. Write the middle term bx using the factors found in step 2 and then continue factor by grouping. So, factor the following trinomial by grouping, complete the outline steps. So here are the step-by-step instructions. Find two numbers whose product is 12 times 6, which is 72, and whose sum is 17. So I'm going to say 8 and 9. Write 17y using the factors from the previous step. So that'd be 8y plus 9y. And then factor by grouping. So I'm going to go up here. I'm going to go 12y squared. I'm going to replace the 17y with the 8y and 9y. And then factor by grouping, which means that I split this in half. What can I factor out of the front? 4y. I'm left with 3y plus 2. In the last binomial, I've got a 3 in common for both, and I would be left with 3y plus 2. So what do both of these things have in common? They both have the 3y plus 2. What don't they have in common? 4y plus 3. So that would be your final answer. So 3y plus 2 and 4y plus 3. One B says factor the following trinomial by grouping, complete the outline steps. So find two numbers whose product is 10 times this negative 9, which is 90, and whose sum is 9. So that would be 15 and negative 6. Write 9x using the factors from part A. So 5x minus 6x would give us 9x, and then factor by grouping. So I'm going to replace the 9x with the 15x minus 6x, split it in half, factor out a 5x in the beginning, and I'd be left with 2x plus 3. I can factor out a negative 3 from this binomial, and I would be left with 2x plus 3. So write the factors that I have in common, 2x plus 3, and the rest that I don't have in common, 5x minus 3, and that is my final answer. Number 2 says factor by grouping. So we're going to use the steps that we used in the last example to do this on our own now. All right, 2 times 4 is 8. So what are factors of 8 that would give us 9? 8 and 1. So I'm going to replace the 9x with 8x plus 1x. I'm going to break this in half. What can I factor out of the first binomial? A 2x, and I'm left with x plus 4. What can I factor out of the second binomial? A 1 is the greatest common factor, and I'd be left with x plus 4. So write what they have in common, and then write what they don't have in common. And that's your answer. That was your answer for the first one. Okay. All right, so factor by grouping. That would give us a negative 24, and we want a positive 10. So that could be a 12 and a negative 2. So I'm going to replace the 10x with a 12x minus 2x. Split it in half. I can factor out a 4x, and I'm left with 2x plus 3. In the second binomial, I can factor out a negative 1, and I'm left with 2x plus 3. So the factors that they have in common and the terms that they don't. And that's my final answer. All right, 2c, it says a factor this. So how is this one different than the one that we just did? Let's see, because we're dealing with a lot of the same numbers, but different. All right, so this will be negative 24. How can I get a negative 10? So now I'm going to do a negative 12 and a positive 2. So 3x squared minus 12x plus 2x minus 8. Break that in half. I can factor out a 3x, and I'm left with x minus 4. The second binomial, I can factor out a 2, and I'm left with x minus 4. So write the factors that they have in common and the terms that they don't. And that is your final answer. (2D), and I know this says example 2C, but I'm looking at this for the D. All right, so factor this, okay? So we can, since we're doing factor by grouping, I would hope that you would see that this is a perfect square trinomial though. So I'm gonna just say my answer right now is 2x plus 3 squared, but I'll show you how I'm getting that, okay? So 4 times 9 is 36. What would add together to give you 12? 6 and 6, right? So 4x squared plus 6x plus 6x plus 9. What do they have in common? A 2x. What would be left? 2x plus 3. These, I can take out a 3, and I'm left with 2x plus 3. So what do they have in common? The 2x plus 3 that's in parentheses, and then what don't they? The 2x plus 3 that's not in parentheses, and since I have the same thing written twice, I can write it as a sum of squares. All right, here is some extra practice I want you to do, so pause the video. And your answers are listed below. So let me know what you're having trouble with. I will say on G, remember to factor out N, F. Let's see, what other ones? That may be it. On those two, remember to factor out your GCF first. On H, you need to put it in the correct order. So you would start like that first, okay? All right, I know I've got this when I can use a grouping method to factor trinomials in the form ax squared plus bx plus c. Do you really understand? So to factor a trinomial by grouping, the trinomial needs to be written as a polynomial containing 4 terms. How could you rewrite 3x squared plus 17x plus 10 so that it can be factored by grouping? So let's see, we would have to have 3 times 10, which is 30. To get 17, that would be 15 times 2. So we would rewrite it as, so it could be written as either 3x squared plus 15x plus 2x plus 10, or 3x squared plus 2x plus 15x plus 10. The order of those numbers that you substitute doesn't matter. What would be the next step in the factorization process? You would need to factor out the GCF from the first 2 terms and the GCF from the last 2 terms.